Welcome, guys. Here we have another question based on ECO 309. The question here says that a monopoly firm has to supply to markets with two different demand functions, as given as you have the first price, which is P1, given as 500 minus Q1, and which is the quantity, and then you have the second price function to be 300 minus the second quantity. So here P1 and P2 are the prices, and Q1 and Q2 are the quantities. So in the two markets respectively. Now here in this question, we are given a total cost function. The total cost function given is 50,000 minus 100Q, right? And then the first question here says that we should find the profit maximizing output. The first solution to this simply implies that I will need to find a profit first. And after getting the profit, I will have to maximize the output. So by formula, we believe that profit is always equals to the total revenue minus the total cost function. But here in this case, I know what total cost function is, but I don't know what total revenue is. So to get total revenue is, this is profit equals to, you can easily compute total revenue by using the price times the quantity sold. The price given to you, or the price times what? The quantity sold. That is the formula for the total revenue, then minus the total cost. Now here in this case, take note, we have two prices. We have price 1 and price 2. So considering the first one, considering this first one, let's say we pick price 1, and then with respective what quantity 1. So what will this give us? The price 1 that we have, the first price quantity we have is 500 minus Q1, then multiplied by this Q1 we have here, okay, then minus the total cost function given to us. So by the time we multiply this and this together, 500 times Q1, that is 500 Q1, minus Q1 times Q1, that's Q1 squared, minus the total cost function. Now we believe that the total cost function is given from the question, and this is a negative sign. Please make sure you open a bracket. So the total cost function is 50,000 minus 100Q. So by the time we open up this bracket, we end up having our profits to be equals to 500 Q1 minus Q1 squared, then minus times 50,000, that is minus 50,000, then minus times minus 100Q, that is plus 100Q. Hence, we have the first profit to be equals to 500 Q1, and here is also, if I have Q here, okay, no problem. Possibly, when I'm dealing with, since I'm already dealing with Q1 here, this is the first quantity, then I can decide to substitute this as Q1. So 500 plus 100, that is 600 Q1, and then followed by a negative Q1 squared, then minus 50,000. So that's how it works. So this is the first profit for the first price and the first quantity. So the next thing is to maximize this profit. Then that means we end up having P prime. P prime simply implies the maximized profit, whereby you need to differentiate profits with respect to the what? To the quantity demanded. So here in this case, that means I'm trying to differentiate with respect to Q1 of the function for profit, which is 600 Q1, okay, minus Q1 square minus 50,000. So my maximized profit will end up giving us, by the time you differentiate 600 Q1, you know, it's just as saying, this is the same thing as saying you want to differentiate 600x, and that will give us 600. Because there's an invisible power here. This power will multiply the coefficients, giving us 600, and then you need to subtract 1 from the power. That is q raised to the power of 1 minus 1, and that's q1 raised to the power of 0, and that is 1. So 600 times 1, we end up having 600. Minus, differentiate q1 square. The 2, you multiply the coefficient I have there. There's an invisible 1 here. So that's minus 2. Then I have q1, subtract 1 up there, and that is 1. So if you differentiate a constant number, you end up having 0. So to maximize profit, at maximized profit, we always have p prime to be equals to 0. The maximizing output, the profit maximizing output, the profit maximizing output is at when p prime is equals to 0. Okay, so then that means we have 600 minus 2q1 equals to 0. Then we need to find q1. That means we end up having 600 equals to 2q1. By the time we decide to divide both sides by, no, we already have 600 equals to 2q1. You can multiply both sides by 1 over 2. 1 over 2. That is, multiply both sides by the coefficient of q1, and that is 1 over 2. This cancel this. 2 cancel 600, and hence q1 equals 300. So we have the quantity, the first quantity for the frame, for the monopoly frame, as 300. And then similarly, we need to calculate the quantity, the second quantity for the monopoly frame. And to do that, so you know what to do, you have to recall from this profit function. Profit is equals to the total revenue minus total cost. And I said total revenue itself represents the price times the quantity sold. That's PQ minus the TC. Then I'll end up having price now. Now, since I'm dealing with the second price and the second quantity, so I'll end up having price 1, quantity 1 for this. This is profit. Please take note. Profit, not price. This is a profit function. So P1 Q1 minus TC. And my P1, sorry, I'm dealing with the second one, P2 Q2. I've gotten Q1 already, so I want to deal with the second profit, the second price rather. The second price is 300 minus Q2. Then I'm dealing with the second quantity times Q2, then minus the total cost. By the time you open up this bracket, you end up having 300 Q2 minus Q2 square. Then with a negative sign of TC. TC is 50,000 minus 100Q. Now I'm dealing with the second quantity, so that means I'll represent this Q as Q2. So I'll end up having 50,000 minus 100Q2. So let's open up the bracket. We end up having 300 Q2 minus Q2 squared. Then negative times 50,000, that is minus 50,000. Minus times minus 100Q2, that is plus 100Q2. So I have 300Q2 here, I have 100Q2. You can decide to sum it together, and that will give us 400Q2, then minus Q2 square, then minus 50,000. So since we have this, we can decide to find the maximizing output for the profit. And to do that, we have these. Recall that we have our profit function to be equals to, we have it as 400Q2 minus Q2 square, then minus 500 minus 50,000. Okay, minus 50,000. So this is what we have. So when we have this, we can easily try to find the profit maximizing output. At profit maximizing output, or to maximize the output, we believe that the derivative for the profit, that's the P prime, the derivative of the profit is always equals to 0. That is, the P with respect to the second quantity demanded must be equals to 0. And then on differentiating this profit with respect to the second quantity, that means 400 Q2 differentiate, I will end up having just 400. Differentiate Q2 square, and that is 2Q2. Finally, with this 50,000. So remember that we are equating the derivative to be equals to 0. So what I'm going to solve out now is I will solve out for 400 minus 2Q2 equals to 2. By the time this goes to the other side, I have 2Q2. Multiply both sides by 1 over 2. And I'll end up having 2 cancel 2. Hence, 2 cancel this. Then I have my second quantity demanded to be equals to 200. So this is what I have. So the profit maximizing output. The first one, Q1, I have my Q1 as, remember I have my Q1 as 300. 300. The output is this Q1 and Q2. Okay, so in the two markets, Q1 is 300, as you can see. Q1 is 300. Hence, Q2 is 200, and then Q1 is what? 300. So that is the correct answer to that. To give an answer to this allocation of output, the allocation of output between the two markets is the allocation of these two by adding this and this together. So the allocation of output between the two markets is Q1 plus Q2. Just have to add them together. And what is Q1? That is 200. And what is Q2? Q1 is 300, Q2 is 200. So the allocation of output between the two markets is 500. So please take note of that. And then the final question here says the prices in the two markets. The prices, the prices between the two markets are P1 and P2. And P1 is given as 500 minus Q1, 500 minus Q1. And remember that P2, which is the second price, is given as 300 minus Q2. So recall that Q1, we computed Q1 as 300, and then we compute Q2 as 200. Hence, we have the prices in the two markets to be equals to, just when you subtract this, you end up having 200, and they end up having 100. So in conclusion, the prices in the two markets, hence the prices in the two markets are 200, 100 respectively. So this gives the final answer to that question. So thank you for watching. Thank you very much.